All right, I want to just show, I have a good example of a project I'm working on right now that demonstrates how intense sometimes a simple project can get. Right now I have a project, very simple Cape Cod style house with a rear dormer on the back. And part of the project is we're going to be adding a dormer up here, just a little doggy dormer for good looks, a front portico on the front of the house for coverage, a side portico for coverage when walking in from the driveway. And then also on the back of the house, we're taking down the deck and this enclosed sunroom, building out a full addition on the first floor and a small addition up here on the second floor to enlarge one of the kids' bedrooms. If I show you what it's going to look like, it's going to look something like this. And then let me see if I can do one thing. So as I rotate around, you'll see the design. This is what we're doing on the side of the house also. And then this is what we're doing on the rear. This entire rear addition and this addition. But also part of the project is we're going to be opening up the interior of the house. We're taking down this wall. We're taking on this wall, which is a bearing wall, because all of the floor joists in the house are a little odd. The floor joists for upstairs go in this direction. The floor joists in the foundation in the basement go this way. But then they switch direction, and as a standard house, you have the center bearing beam, and the floor joists go front to back and front to back. This area over here is a little odd. You don't run into this that often. So because we didn't do any pre-demolition work, we're still assuming that this is the bearing wall line through the house. So we're taking that out. So to get this to work correctly and to do the construction drawings, we're trying to take a look and figure out how we can do our structure. So now it's starting to get a little bit complicated because we're opening up the interior of the house so much. So this is going to be a beam line front to back here. This is going to be a beam line front to back with a point load here brought down into the basement to a new column. And to support the second floor, which was over a wall below, now that we take the bearing wall out, I have to put in a beam here to support the second floor. And I have to put in beam here to support the new second floor, a trimmer beam to spread the weight out to the rear wall and to the existing beam. So to pick up all this weight, I'm going to have this beam going to here, a new beam going to here. The weights will then be picked up by this front to back beam. And there's always more than one way to do the structure. But to me, looking at it a couple of times, this seemed to make the most sense. So there will be one column here with a large point load going down into the basement, which is on this beam line. But this beam wasn't designed for that kind of weight, so there's going to have to be a new column down here on the beam. Or as an option, they could elect to put in a steel flitch plate reinforcement or replace it with a steel beam, which most people don't do. And then from this point back will be another new beam to a post here. Now that's just all the beams that I need to design. Then I have to get into the idea of how am I going to go about designing these beams. So then we slice a couple of sections through the house. This right here is where the new beam is going to be. So this is the beam. These are the floor joists going left to right in that odd pattern they have in the house. These are the new ceiling joists in the addition going front to back of the house. New roof rafters front to back. So I'll be picking up half the weight of this wall going into the wall and then down into the beam. Half of this span of the ceiling joist going into the new beam. Half of these ceiling joists going down into the exterior wall, and this full length of roof going down through the wall into the beam. All that has to be calculated. And so this is my calculation. An enlarged family room beam left to right. I have to name each individual structural member. If you look at my project menu, this is what I've already calculated for the house. A bedroom ceiling beam upstairs, a couple of kitchen beams and trimmers. I had to calculate the structural header on the back of the addition because I've got this trimmer sitting on top of this header. So this point load over here is excess weight, so it's got to be engineered. And I've also got the enlarged family room beam, which I am working on right now. So this gives me a couple of options. Right now, if I do 2 microlambs with a steel flitch plate with a 1-inch thick steel flitch plate, it passes. But some guys will say, well, I don't want to do a single 1-inch thick plate because it's a lot of weight. The rigging gets to be a pain, so they like to do it in individual members. So maybe then I switch to 3 microlambs with 2 separate steel flitch plates, and maybe I'll get away with a 3/8. All right, that doesn't pass. So now I got to switch to 2 half-inch steel flitch plates. And they'll have everything pre-drilled at the fabrication shop and then put it up one piece at a time and bolt it all together. Now I'm not done still. If I look at my loading diagram, this is my beam. These are the weights that are being supported at each end of the beam. On the left side of the beam, I've got 4,000 and 3,800 pounds. So I'm going to now have to design the post that sits on the foundation. At this point over here, this is the weight that's going to be going into this beam. So then I have to go back and start a new beam calculation with a couple of point loads, which will be this module on my structural program. So I have to take all the weight from the roof to the first floor, to the second floor, then down to the first floor, and then down to the foundation plan. So that just gives you a little glimpse into how hard the structure can be to do on what should have been a relatively simple job. And once you start taking out a couple of walls, then you really have to get into it. Then also at the very end of the job, this is something new that the plans examiners are starting to look at: the braced wall construction. Every wall in a house has to have a certain amount of solid sheathing on the outside. They call it a shear wall when you're near the water. When you're away from the coast and you're away from the higher wind zones, it's named a braced wall line. But just for drafting situations, we call it a braced wall line, a BWL. And you have to have a certain amount of solid plywood. So this would be a segmented solid shear wall. So with this one. This wall in the back, I'm probably going to go through the calculations and take a look at it with all these openings in the wall, the triple window, big sliding glass door and triple window. I probably won't have enough solid sheathing on this wall, so I'll have to redesign it, and in this case it would be called a perforated shear wall. And then I might have to upgrade the nailing patterns on the plywood, maybe have it sheathed with thicker plywood, or in a worst case scenario, I would have to do plywood on the outside, plywood on the inside, and then have it covered with sheetrock. But these are all high wind requirements for Long Island because we are in a 130 mile an hour ultimate wind speed zone. So that gives you another glimpse into some of the other things we have to take into consideration when we're doing the drawings. That will wind up going onto the construction drawings. We'll have, these are my special nailing patterns for the plywood that goes over the glass. And this is my shear wall segment plywood detail right here and right here.